Hi, welcome to the Level 3 Cambridge Technical in Engineering, Unit 4, Principles of Electrical and Electronic Engineering. This is the exam revision for the 2017 June series of exams, so you've got that coming up in a few weeks' time. These videos should be watched in combination with the Year 11 Systems and Control, because some of those videos cover the basic principles that we'll also be talking about here, and we won't cover the basics in so much detail, so you may need to go back and watch those videos. Okay, we're basically going to look at two previous papers, the 17th of January paper and the 24th of May paper. Okay, and what we're going to do is we're going to look at questions. So we're going to base this as a step-by-step through these two exam papers, and while we're stepping through, we're going to look at similarity in the paper layout. So you're going to see that the question paper starts with very similar questions from very similar learning objectives within the specification. So question one, divided into a number of parts, A, and B, and how it deals with some of the basic fundamentals. So for example, here we're looking at things like Ohm's Law, power, energy, and some of the basic formula that you'll be using. We're going to be referring to the formula booklet which you'll be given, and we're going to just get you familiar with finding the right formula, because although you've got power here, for example, you've got options on what to apply where. So it's a case of having a little bit of a practice so you know which of these applies in which situation or which scenario. So we'll be coming back through this formula paper. If we haven't covered it in the exam questions, we'll then come back and work our way through these and cover it as part of theory at the end. So let's get started. Okay, did a little pause there, so it's not magic, the paper's just been moved out of the way. So let's have a look at this first question then. An ammeter with an internal resistance of 25 ohms is used to measure the current in a 150 ohm load resistor. The supply voltage is 24 volts. Okay, my approach to this, and my approach to a lot of these questions, is to draw or redraw the question so that I understand what's going on, what goes where, and there's space on the exam paper for you to do that, and I strongly recommend that that's what you do. So let's have a look at what we've got. I'll put that to one side there, and I'm just going to do this on a separate piece of paper for now. So I'm going to keep my question handy. Like so we're on Unit 4, and we're on question 1, and we're going to be looking, you can sort of pretty much be sure at some point early on you're probably going to need Ohm's Law, so I'm going to write that up straight away. V over I equals R, because I think that's definitely going to be relevant. And again, I'm keeping my formula booklet handy. I'm looking through the question, it's calculating the actual current, that's I, in the circuit. Calculate the power, so power is going to be P equals VI. So I'll make a little note of that to myself. P equals V times I. Okay, so I'm just getting a little bit thinking about the question, getting myself prepped. An ammeter. If you don't know already, and you should, an ammeter measures current, okay, and it has to go in series. So an ammeter. So let's draw a little diagram. So we've got 24 volts. So let's give ourselves a power source. I'm going to put in a battery. Now an ammeter basically connects in series. So I'm going to write A there. And then when they talk about a load, all electronic circuits have to have some sort of load. They have to do something. Otherwise you'd just have electrons going from the battery around the circuit, and the battery effectively would be short-circuited and the battery would just discharge, basically. So the load gives the electrons or the energy something to do. So there we have a circuit. Now they told us that this is 150 ohms. So there's 150 ohms. And they said the internal resistance is 25 ohms. So every component in an electronic circuit, an electrical circuit, will have some form of resistance. Now sometimes it's explicit and we use it for calculations, and sometimes it's implicit and we sometimes ignore that depending on how accurate that we're going to be. Okay, so we know this is 24 volts. Let's call that 24 volts, and let's have a look what it's asking us to do. Calculate the expected reading on the ammeter. That's current, that's I. So I'll cover that. So question 1a, part 1, I equals V divided by R. So as they're saying, it's 24 volts divided by 150 ohms is equal to 24 divided by 150 equals 0.16 amps. Capital A, because it's a unit in the SI system, and it's also the scientist's name, ampere. So amps. 0.16 seems like reasonable. Amps are usually, in small electronic circuits, amps do tend to be less than 1. So it's quite common. So that I'm quite comfortable with that as an answer. It would make sense in a small circuit like this to have less than 1 amp. So that's pretty good. Calculate the, and I've underlined this, actual value of the current in the circuit. Okay, that's going to give you a moment of pause and you think, well, I've just calculated the current in the circuit. Well, you have that circuit. Okay, this is this implied resistance that we didn't calculate. So now we've got an interesting situation because we've got some form of resistance and another form of resistance. And if you remember back to, and again this is why you might want to go and look at the year 11 systems and control videos, is because it covers the basics of things like resistors. So we have the resistors in series. So we have R1 plus R2 for the R total. So the real resistance in this circuit is actually 150 plus 25. I'm going to write that down just so the examiner knows what I'm doing. So I've got 175 ohms. So I've now got 24 divided by 175 this time, which means the actual current in the circuit. So this would be 1A22. The actual is, let's pop this in again, 24 divided by 175 equals, so 137 ohms. 3 decimal places is fine there. If in doubt, always go to 3 decimal places unless it asks you to go otherwise. So, question 1A123. Calculate the power dissipated in the ammeter. Power is equal to, we've prepped already, the voltage times the current. Here's a moment of pause, because I've got the voltage is 24 volts and I've calculated the current twice. Okay, this is the last thing that I did. The examiner tends to lead us in a certain direction. Okay, so they're introducing elements one stage at a time. I would make the assumption in the examination, and you'd be correct to do so, is if the examiner's taken me through these steps, then this value for I is likely to be more relevant to calculating the power for this circuit, because the examiner's taken me in that direction. And if he wanted me to use this value, he probably would have rearranged it, or she would have rearranged these the other way around. So he could have asked for the actual value and then said, well, ignoring the ammeter, what current would you get, and you would do it that way. So there's a sort of guidance, follow the logic of the question. So at this point I can say, well, I think it's 24 volts, and that would be times 0.137 amps. So that's going to give me 24 times 0.137 equals, can you just see the decimal point there? So I've got 3.288, 3.29, and the unit for power, well, the unit for power, well, let's leave that for the next video. So I want you to go away and find out what is the unit for power. Go and investigate that, and we'll find out if you're right when we look at the next video.